Good afternoon. My name is Santosh Rao, and it's a privilege to be here today. I have the distinct honor of having been in front of this group the very first time this was webcast back in 2010. So some of you heard me say that last time I did it. So SFD4, I believe that was back in 2010. We were talking about ONTAP 8.0.1. That was my first appearance in front of this group. Survived then, but didn't get called back till 2018. So barely survived, I guess. I am fortunate to be back again. I know we had a great session last year, and very much appreciate the opportunity to be back again. I lead a team here at NetApp that is focused on our AI offering from NetApp, and we are a team of data science engineers, data infrastructure engineers, vertically focused solution engineers. And we've come a long way since I last stood here in front of you. A year and a half ago, when I was here, we were talking about the evolution of Hadoop and the evolution from Hadoop to AI. And at that time, it was a strange conversation, I guess. But today, we've got AI much more in the headlines and Hadoop much less so. There's a lot more shift in the vendors when you look at Cloudera, Hortonworks, MapR, and so on. And so we'll talk about where we've been, what we've done in the year and a half since we last saw you. So first, let's just introduce what we mean by NetApp AI and what is a full stack AI and what it means to run from edge to core to cloud. We've talked in the past about data pipelines and the fact that data has its own life cycle, starting from ingestion to data aggregation and data curation, cleansing and preparation, and then the process of applying machine learning or deep learning using acceleration techniques, whether it be Spark-based machine learning or, more interestingly from our perspective, GPU-accelerated deep learning. And so what we see here is that life cycle of data is actually an instance of what NetApp has been working on called the data fabric. So data fabric for a NetApp perspective has been hybrid cloud, and clearly the edge is very much now a part of that fabric. Going from edge to core to cloud is that whole life cycle of data fabric. So specifically, what does this entail? You're looking at systems at the edge that have a small form factor, that are software defined, that can quickly destage data, and perhaps work through last mile infrastructure that is able to get near edge solutions. In the data lake, when we talk about data lake, these are really a collection of data sources for structured, unstructured, variety of different databases, maybe file systems or S3 data lakes and so on, that are then used to aggregate data, curate data, and then feed data into these training systems. Training is probably the biggest part of the change that we've seen in systems architecture, and that's where I'll spend most of my time, going into training and a little bit into inference. But as we look across our NetApp portfolio, what we have brought to bear here is a pod-like architecture, which is where I'll spend most of my time, focusing on training compute with storage and networking that delivers the high performance that you need for these immense training jobs that may run weeks or even months on end. So what are the use cases that are driving this whole space around AI? Why are we seeing so much uptick in this space? We have, since the last time I stood in front of you, we've actually had over 50 customers deploy AI solutions. And we have hundreds more where we're seeing active engagement. And I'll take even a simple example like smart cameras and smart cities. I mean, the potential is immense when you start looking at every city that is thinking about what smart cameras can do for surveillance, for public safety, for smart traffic management, and so on. And we are now seeing an ecosystem that is simplifying AI, so much so that there are software vendors talking about code-free AI. Code-free AI, as in you've got a library of models, you've got data that is being gathered, and you can start applying models to data to start looking at use case level applications. So when you look across these verticals, across these use cases, we're seeing a rapid uptick in particular verticals. So automotive is no surprises, but so is the case with healthcare, with financials, with telco service providers, and public sector as well. Each of these, we're starting to see almost every major provider in that vertical starting to go after these use cases and look at how they invest, what is their first investment, what is their next use case, and so on. What does NetApp bring to this space? We have built out converged platforms that start small and scale big. These are platforms that we build in conjunction with NVIDIA, with the DGX server line today. And we have started to broaden that beyond NVIDIA to include server partners like Cisco and other partners as we look forward. Recall, we talked about the pipeline as encompassing data lakes, training, inference, and the cloud lifecycle. This is one part of that pipeline, but it is where a tremendous amount of budget spend is happening right now. The reason for that being the high performance nature of these workloads, the thermal and cooling considerations that go into these workloads. As an example, these servers are 3.5 kilowatt each. When you look at the 10 new servers, the DGX2, those are 12 kilowatts each. If any of you will be at Supercompute next week in Denver, we will have some fascinating displays of real hardware running in liquid-cooled cabinets with negative air pressure. Those are cabinets that are hosting upwards of 50 kilowatts per cabinet, 50 kilowatts per cabinet. So as you start to look at this hardware, there's a tremendous amount of supercompute being brought to the masses. So the real transformation that's happening here is what used to be supercomputing, only affordable to extremely expensive HPC centers, is being brought to the masses, is being brought to the enterprise, and is transforming computing as we know it, and changing use cases that were unsolvable in the past. So that is
so just to try and translate that and read it back to you, if I may, what you're saying is you're using your years of hardware design experience from building storage arrays and then redoing it for GPU clusters or TPU clusters.
We're using our years of experience with FlexPod, which is our converged infrastructure, to start to build pods for the AI market with a variety of compute offerings, the best of breed being NVIDIA DGX compute. This is the NVIDIA DGX.
Right.
And we're starting to expand that across a choice of compute vendors, whether that be NVIDIA, whether that be Cisco, or any of our server partners. But more importantly, we're expanding it into a choice of cloud as well.
So you're going to get a cloud to host these units?
So when we talk about edge to core to cloud, the software stack that runs on these units can run in the cloud. The hardware can run near cloud in co-location service providers. I'll talk about that in a little bit. And these systems can run on-premises as well as at the edge. And the NetApp Data Fabric starts to build a federation across that, creating an edge to core to cloud pipeline that we call the NetApp AI control plane that I'm going to
So the hardware is one thing, and then there's a software pipeline on top to run their tasks.
Exactly.
The neural nets and stuff like that. Okay, great.
So there are 4 elements to something as complex as this. Firstly, AI is entirely focused on data scientists, and they don't understand hardware. So we want to abstract out as much of the hardware, and the way we go about doing that is simple automation. We use Ansible to completely automate the deployment from rack and stack onwards to bare metal provisioning with Ansible. And once we've done that, we use Kubernetes in Kubeflow to be able to automate the lifecycle management with our AI control plane. Delivering performance on these systems is a function of both capacity, scale, and the ability to do random and sequential workloads. And I'll actually go into some fascinating detail on what we've learned in those over 50 customer deployments. We'll go into what does that pipeline look like, what does system architecture look like for this system. So first, the hardware itself. It is a 100 gig system as far as Ethernet is concerned, also offered with InfiniBand and our EF series product, but clearly a 100 gig high performance network ingress system. The reason that these are high performance network ingress is because you've got to look at these pipelines as constantly flowing data. So let me take an example. We have a financial customer doing 50 neural network training jobs that are running in parallel. And these 50 jobs have about 20 terabytes of data that they're pulling for the footprint to train those jobs. Which means if the training job runs for a day, every day you've got 15 to 20 worth of data flowing through that pipeline into these training platforms. So imagine these platforms now starting to become freeways where you've got enormous amount of data traffic flowing through, constantly running a training job. Once you're done with the training job, the next one comes in. That's just going to get more and more clogged. You can't build wide enough freeways fast enough, so what do? You push hardware to the edge. You push AI training jobs as close to where the data is ingested and as decentralized as you can. And that's a perfect use case for the data fabric. What the data fabric is all about is a fabric of endpoints. And the edge is the new killer app for that data fabric. And just like we were talking about data fabric 6 years ago when nobody else was talking about it, we think that AI now gives a whole new life and a whole new set of use cases to the data fabric.
Well, your data has to be close to your TPUs.
Absolutely.
Because you're thumping the data around at very high volumes.
The number one question, which we will go into in system bottlenecks and architecture, is the VP of IT saying, I spent $1 million on this hardware, I'm not getting 2% utilization, what are you guys doing? So we'll go into exactly what that conversation entails. But first, what we bring to the table is the seamless scale of cluster ONTAP. The conversation we were having in 2010 that's paying off for us now. 2010, we talked about all the benefits of seamless scale out. And here is an example where data in petabytes is an everyday enterprise conversation. In fact, I talk to our teams as there are 3 steps in an AI journey. The first step is about 100 terabytes of data. The customer is just starting to experiment with AI. They want a single node AI system with about 100 terabytes of data to give them AI training. That's the starter solution. Once you've gone from there, the next step is you're going to build a POC that you're taking into production for one use case. Maybe it is traffic surveillance, just one use case, one line of business. So that then starts to expand into about a petabyte of data. You've got a petabyte worth of trained, labeled data that is going to go into production management for that pipeline for one use case. Now let's expand that into maybe it's a city or state local government and all of the use cases for that particular line of business. You start to get into at least about 10 petabytes of data. And as you expand into the full subset of all of the lines of business for the state government and all of the use cases, you're looking at 100 petabytes of data. Now, what is common across that 100 petabytes? It has to be a namespace that is accessible for retraining. So what has changed between 100 petabytes of data in the cloud and 100 petabytes of data for AI is that you need to be able to pull up data randomly out of that 100 petabyte data lake. Why do you need to do that randomly? Because of bias. AI algorithms cannot afford to get overtrained on a selective subset of the data. So what you need to do is constantly open up the data lake, constantly do random selections of data for retraining, and that process could happen every 2 weeks, could happen every month. And so here's a fascinating story now, where we've gone from being able to build massive data lakes to now saying, I want to randomly read anything in that 100 or 200 petabyte or even an exabyte data lake. How do you do that? So those are the interesting system architecture challenges, the performance challenges, the data tiering challenges that start to open up design and possibilities. Now, when we talk about these systems, we are actually deploying large-scale systems. If you Google for SPER Bank, SPER Bank is the world's largest AI supercomputer deployed on NetApp. It actually looks far more menacing than this. All I have here is the compute. Obviously, I'm not showing the drive shells. But the SPER Bank is 75 DGX2. Each of these is a DGX2. Each of these is 12 kilowatts of power. And we're talking 75 DGX2 being deployed at SPER Bank. We've got telco providers in APAC that are deploying 25 of these. We've got supercomputing and scientific computing facilities deploying 70 of these. And so last year when I stood in front of you, March, I think, of last year, this was a concept. Today, this is being deployed. And I've been here a long time. I saw many technologies right through. I did not see this kind of uptick. We'd see people buying one server and saying, OK, I'm going to kick the tires. But to go from where we were at conversations to seeing financial customers, telco customers, government, federal and state, not just in the Americas, but worldwide, Eastern Europe, APAC, Mideast, deploying these kinds of massive systems is eye-opening for us.
How easy is it to switch out the DGXs? Because those GPUs, TPUs, they rotate fairly quickly.
The DGXs bring with it the NVLink backplane, which really gives you the ability to do linear scaling across more than one GPU complex. So when you're looking at what is it the DGX does, the magic sauce in the DGX is the NVLink. It allows you to get that linear scaling of performance as you go beyond 8 GPU into 16 and beyond that into tens of these nodes.
The problem that we have, or I've seen, is that quite often you end up with orphan clusters of GPUs that aren't worth running because they're so slow after 3 years that they're not worth powering anymore.
That's a great lead into a conversation I'm going to have about what we're doing with service providers.
I knew that.
Service providers are filling in those shoes to say, you know what, we'll take the CapEx cost and we'll make data scientists productive.
Yep.
You just don't need to go into a public cloud and move your data, petabytes of data into the public cloud.
Yep.
The challenge that customers have is data has gravity. You can't move 100 petabytes of data. If it's not in the cloud, you got to work where the data is.
Yeah, you can't afford to put 100 petabytes in the cloud because of the network transfer rates.
And you got to think about egress costs. This is not a one-way traffic. This is two-way traffic, because when you train a model, you're going to push the model to the edge. If that model is a neural network on your phone, and you got 300 million phones deployed, that's 300 million phone updates being pushed to the edge.
Yeah.
And imagine if that data model was being trained in the public cloud, you got egress traffic that is driven by a function of the edge endpoint. So there's some fascinating system design there.
So are you on the top 500 list at all? Or are you powering any of the top 500 supercomputers?
We are certainly powering the top AI supercomputers. So when you look at the largest AI deployments in APAC, we are deployed with them. When you look at the largest, like I mentioned, the largest AI supercomputer in EMEA, we are deployed with them. So we've got deployments on some of the biggest ones.
And so who is the market you're going after for this? Is it the research, or is it more the commercial side?
That's a great question. I get asked this all the time. And what is most fascinating to me is what used to be research, computing, high-performance computing, is coming down to the enterprise. And this is the biggest transformation that is happening out there. Things that you could not afford to do unless you were a Lawrence Livermore Labs or NASA or something like that is coming down to the enterprise in liquid-cooled cabinets that are self-contained. We are not talking about massive plumbing to run water cooling through your data center floors. We're talking about cabinets that are self-contained. So this technology is coming to the enterprise and is coming to service providers who are making it affordable for the enterprise. So it's not just enterprise as in your Fortune 100, Fortune 500. It is mid-market customers that have to compete with Walmart and compete with Amazon, but that can do that using service providers. And of course, they can do that with the public cloud. So what does it take? It takes an entire village. And we call that village NAPN, NetApp AI Partner Network. Starts with, obviously, the infrastructure, which begins with partners like NVIDIA, but a choice of compute from our perspective. So we're in a good spot here because we look at data as the new gold. And that gold has a longer life than all the containers that carry it, which is the compute ecosystems that go with it. So as you look at these data pipelines and these data assets, they're going to live a life of decades. And we're going to hopefully be the host of that data, working across a choice of the rest of the ecosystem, which means a choice of compute, a choice of software ecosystems as the data sources for that data changes over time, a choice of partners that will deploy worldwide, and more interestingly, different types of consumption models, whether it be public cloud or service providers. All of us saw the 2008 VMware wave. 2010, we were talking about virtualization, and we saw the service provider uptake for VMware at that time. You're seeing the same rise of service providers now, driven by 2 or 3 factors. The first is we talked about power and cooling. Customers can't build data centers that can host 50 kilowatt racks. They're blowing out power for their entire data center floor. So they're looking at who can host this for me, especially when you look at racks that are tens of these racks. So an entire new market of service providers, names that we may or may not know today, but that are emerging and changing the space, are starting to come up. And I'm going to give you a sample of this. We're working with over 10 service providers, jointly with NVIDIA, on a program to bring 3 types of alternate consumption models for AI. Now, here's the most fascinating thing. A year and a half ago, I didn't know these names. I couldn't talk about these names with you. We are moving so fast that in a year and a half, we've created a whole ecosystem, and put in place a service provider ecosystem. And we've got 3 types of deployments that we're starting to incubate with these service providers. So what are these 3 deployments? The first is the most basic, which is every co-location partner should be able to host hardware. That's the most basic definition of a colo partner. That's in place. The second is a test drive. By a test drive, what we mean is we incubate the rack at the partner. A customer can try it out as much as 3 months. They're happy with it. They choose to deploy in their data centers or choose to deploy at the service provider. The third and most intriguing is AI as a service. And the service providers are trying to distinguish themselves from the public cloud in saying that you can consume AI by the month. So you can come in and say, I want a POC project. Maybe I need 3 months of GPU compute infrastructure with data co-located, and I can consume that as a service. And to your point, if the hardware needs to be tech refreshed, that's your problem, Mr. Service Provider. It's not my problem.
All right. So the couple of questions is, so what you're saying there is that the GPUs and the TPUs are like chassis level, so I'd have to replace the entire chassis, which is as I expected. Like there's not some magic going on here where I can slide them in and out as I need to. That's what you're saying.
Yeah, and the reason you don't want to do a GPU level replace is because the overall system performance has to evolve with these GPUs.
But you're saying the internal architectures, the backplane buses, and all that sort of stuff is also evolving.
Exactly.
I guess the other question here is that if the biggest challenge about moving into a colo is the same as moving into the cloud, you've got petabytes of data to move around, and colos are often ill-prepared for that. They're often under-specced bandwidth-wise. And the other challenge that I've seen people doing this type of class of data compute, I call it data compute, not AI, because data compute's been around for decades, it's not new, is when you try and move that data out, it takes days or weeks. So one of the problems that we've been facing is building custom apps to shift petabytes of data around, even on a 10 gig or 100 gig internet pipe, is weeks or months of time.
And that is where smart technologies from NetApp like FlexCache come in, where if you've got your master data co-located, let's say, in a data center in Utah, and you've got the colo provider maybe in Hillsboro in Oregon. Now you've got the ability to take a FlexCache cache volume that is placed in Hillsboro with the origin in Utah. And you do all of the data prep in Utah. So you look at CPU infrastructures that may be co-located by the master data in Utah to prepare the data sets.
Yeah.
Now, there's a difference between data lakes that may be petabytes in scale and cleansed, curated, labeled data, which is a smaller fraction of that. So as you start to look at these training cycles, you've got these data curation jobs that are running close to the master data, reducing the footprint down to labeled data sets.
Yep.
And now the labeled data sets need to appear close to the GPU.
So what you're saying is you redact the data at source, try and cleanse it in some way. That's going back to the old days of ETL, data ETL load, where you had to take the data out and then clean it before you did anything with it. That's not what we're trying to achieve with AI, surely.
No.
Well, that's where the brute force approaches start. Now, where it evolves to is semi-autonomous labeled data close to where the data is being ingested, where the data is being conceived. So over time, constantly you're going to see a left shifting of intelligence moving to the edge, which means you're going to see filters, AI inferencing filters at the edge that start looking at bifurcating your data as it's coming in, looking at labeling data as it's being ingested, semi-autonomous and autonomous labeling as it's being ingested. So it's just a fascinating time. If you're a data geek, as all of us are, and we sort of look at what is compute doing to this data and what is system architecture evolving.
I get what you've said that several times, so I'm sort of trying to bunny hop over the marketing hype you keep spinning out. And the other challenge I've got with AI is it's moving so fast that if customers get into it, like the struggle that I've seen is a lot of people who are in enterprises, they don't understand AI infrastructure at all. They don't understand moving petabytes of data around. They don't understand low latency networking. They don't understand GPU clusters. They don't understand backplane architectures in the servers and how to optimize. They're not even used to the idea of a 15 kilowatt rack, much less a 35 or a 50 kilowatt rack. Do you struggle? How much effort do you have to put into selling this product? Because usually you have to ram it down their throats, and it takes 10, 15 sales reps and TMEs to make it work.
And this is where we have completely changed our approach. We are building fully automated AI control planes that automate the rack and stack and then the deployment with Ansible, and then build an AI control plane with Kubernetes and Kubeflow that I'm going to go into and show you what that looks like. So this conversation 9 months ago, I said, yes, that is a challenge.
Yep.
Today, we can give you a Jupyter notebook as a service, and you can pick if you want 2 or 4 GPUs, and off you go.
Okay. All right.
So we have put programs in place, like I said, try and buy AI as a service, and we are adding service providers that go with it.